Welcome friends. In this video we are going to discuss the unit 10 test paper of current electrification grade 10. Before start the discussion, we have to correct some errors in this paper. Second, we have to correct this table, data table. Correct orange as 3, the value of orange as 3. And next, red 2. It's okay, correct. And this is not brown, this is black. The value of black is 0. We have to correct orange as 3 and the red is 2. It's okay. It's not brown, it's black. And the value of black is 0. Okay. And the next error is here. Yeah, here. The value of red is 2, it's okay, it's correct. The value of green is 5, it's okay, it's correct. It's not black. Make this as brown. And the value of brown is 1, no? Value of brown is 1. Before start the discussion, we have to make sure about those errors in this paper. Okay, let's start the discussion. First question, a fixed value resistor is indicated below. They given us a resistor with 4 color code. First color is orange, second color is red, third color brown, and fourth color gold. Value of orange is 3, red 2, brown. It's not brown. Here is the black. No black. Black is 0. Then to find the value of a fixed value resistor, we use the color code system called 4 color code system. Then the first color code from left side to right side is tens place, and the second color code is ones place, and the third one is index value, and the last one is tolerance value. We can remember as to it, tens place, ones place, index, and the tolerance value. To find the resistance value, we have to multiply the value of first 2 color codes, that means tens place and ones place, by the third color code, that means the value of tens place and the ones place should be multiplied by the value of third color code, that means the index value. Okay, here the value of tens place is 3. Here 3, and the value of second color code is red, that means 2, and the value of the index is now here 0, that means 10 to the power 0. 10 to the power 0. 10 to the power 0 means the value of 10 to the power 0 is 1. So to find the value of this fixed value resistor, we should multiply the values of first 2 color codes by the third value of the third color code. Accordingly, we should multiply 32 by 10 to the power 0. 10 to the power 0 means 1. Accordingly, the value is 32. To find the tolerance value, we should multiply the percentage value of the fourth color band. Percentage value here is 5%. So we should multiply 32 by 5%. The value of 5% of 32 is 1.6. 1.6. So the correct answer is first one. The value of this fixed value resistor is 32, and its tolerance value means 32 into 5%, that means 1.6. So the correct answer for the first question is first answer. First one, 32 ohms and 1.6, plus or minus. We know that the tolerance value may be plus or may be minus. You can correct your answer. Okay, let's move to the next question. Next question is, the following diagram shows the way of connecting A, B and C identical torch bulbs to a circuit. The bulbs with the highest brightness and the lowest brightness are. Okay, in this question they asked to find the bulb with the highest resistance and the lowest resistance. So here you have to know some clue points in the lesson. The first point is, here you can see the bulb A is connected to the circuit in series method, and the B and C are connected in parallel method. We know that in series method, the resistance of the conductor is greater than in the parallel method. As an example, if we consider the resistance at point A is 2 ohm, A has 2 ohm, and the resistance on the B also 2 ohm, and the resistance value of C as 2 ohm. So if we calculate the resistance of those points, here resistance at A is 2 ohm. Resistance at B and C, here is the parallel method. In parallel method, we should find the value of the resistance by adding reciprocals of the values. That means 1 over 2 plus 1 over 2. So here the resistance is, we know that 1 plus 1 is 2, denominator is same, 2 over 2 means 1 ohm. Here the resistance at bulbs B and C are 1 ohm. Accordingly, we can conclude that in series method the resistance is high. In series method resistance is high. In parallel method resistance is low. Okay, you have to remember it. Okay, the next clue point. Next point is, when increasing the resistance, the current flow through the conductor is decreasing, and when decreasing the resistance, the current flow through the conductor is high. Accordingly, bulb A resistance is increased, resistance is high, then the current flow through the conductor is low, so the brightness of bulb A is low. Brightness of bulb A is low. You can write here lowest brightness as bulb A. The bulb with the lowest brightness is bulb A. Then what will happen to bulb B and C? At B and C, the resistance is low. Resistance is low means the current flow through the conductor is high. Then the brightness is high. The highest brightness may be B or C. Then let's look at the answers. First answer A. A means the bulb with highest brightness. No, it's cross. Bulb B. B means the bulb with highest brightness. No, it's wrong. Bulb B and A. Bulb B means here the resistance is low, then the brightness is high. Okay, so okay. Correct. And the second one, A. At A, the resistance is high, so the current flowing through the conductor is low, then the brightness is low. So it's a correct. Correct answer is the second one. B and C, third one. B. B means the resistance is low, then the current flow through the conductor is high, then the brightness is increased, higher. But the C means it's also connected in parallel method, then the brightness of the bulbs B and C are equal. So third answer is not correct. C and A. C means in parallel way, that means the resistance is low, then the current flowing through the conductor is high, then brightness is high. C and A. Accordingly, C and A answer also we can take as the correct answer. Okay, let's move to the next question. Two metals that can be extracted by electrolysis are. This is not an question relates to current electricity lesson, but let's discuss this. Okay, you know that the activity series, there's a series called activity series. Uh, in activity series, at the beginning of the activity series, metals with high reactivity. You want to remember that metals with high reactivity can be extracted by electrolysis method. Accordingly, at the beginning of the activity series, there's potassium and sodium. So the correct answer is third one. You have to remember metals with high reactivity can be extracted by using electrolysis method. You have to remember it. It's a point. Okay. So the correct answer is potassium and sodium. Third one. Next question. Which of the following is a symbol of a permanent resistor? Answer is first one. The first one the first diagram demonstrates a permanent resistor, and the second diagram demonstrates a variable resistor. This arrowhead demonstrates we can change the value of this resistor. And the third diagram demonstrates a light dependent resistor. This invert two arrows represents this resistor as a light dependent resistor. And the fourth symbol is the symbol of a diode. You can learn about diodes in details in grade 11. Okay. So the correct answer is first one. Next question. I told you to correct this black as brown and the value as 1. So let's find the true range of values that above resistor could be. That means the tolerance value. Tolerance value change. Range. Okay. As in previous question, we know that the first color band demonstrates tens place and the second one ones place and third one as index and the fourth color band demonstrates tolerance value to it. Okay, you can remember it as to it or something. It's your choice, huh? Okay, then the value of first color band tens place is 2 and the value of second color band is ones place is 5. That means 25. Sorry. 25. Give a minute. 25. And the value of third color band is 1. So we should multiply the values of first two color bands by the third color band value, then 10 to the power 1. We know that 10 to the power 1 means 10. Then 25 into 10 means 10 to the power 1 means 250. Then the value of the fourth color band. Tolerance value is 10%. That means in this resistor the tolerance value is 25. That 10% of 250 is 25 plus or minus. So 250 plus 25 means 275. Minus means 225. So the correct answer is first one. Second one no. Third one no. The correct answer is first one. You can correct your answers by pausing the video or something, or taking a screenshot. Next question. A diagram of an electrical circuit is given below. When open the switch. Open the switch means they given us in brackets off of the circuit. The reading of the voltmeter which is connected to the X and Y terminal is known as. You can see the X and Y terminals here and the voltmeter connected in series method. We know that in voltmeter we can measure the potential difference. We can measure the potential difference for the voltage. Okay, let's look at the answer. First answer, conventional electric current. We know that to measure the conventional electric current, we should connect an ammeter in parallel in series method, to measure the electric current, we should use an ammeter. So here is an voltmeter, so first answer is incorrect. Second one, electromotive force. What's electromotive force? Electromotive force means in an electric cell, the force exerted by negative terminal to release electrons. We know that the current flow through a circuit by in positive from positive terminal to negative terminal direction, and the electrons flow from negative terminal to positive terminal. I'll say again, current flow through positive terminal to negative terminal, but the electrons flow from negative terminal to positive terminal. Electromotive force means in an electric cell, the force exerted by negative terminal to release electrons. Can you understand? The force exerted by negative terminal to release electrons. So to measure the electromotive force, we can't measure it by connecting a voltmeter between positive and negative terminal. We can't measure it. Third one, potential difference. Potential difference means potential between the potential between the two terminals of the cell, terminals of an electric cell. Okay, so here the voltmeter is connected between the two terminals of the cell. So the third answer is correct. Potential difference. Potential difference is equal to the electromotive force when electricity is not drawn from the cell. Can you understand what I'm saying? When electricity is drawn from the cell, the electromotive force and the potential difference is different. Okay. But when electricity is not drawn from the cell, the electromotive force and the potential difference is same, equal. But here in this circuit, electricity, you can clearly see that electricity is drawn from the cell. Okay, electricity is drawn from the cell. But in the question they say when open the switch, that means off. When off means electricity is not drawn from the cell. Electricity is not drawn from the cell. Okay. Then electromotive force and the potential difference is same. I will write what are the points of I said. When electricity not drawn from the cell, EMF means electromotive force is equal to potential difference. Okay, we have to remember this point. When electricity not drawn from the cell, electromotive force is equal to potential difference. So the answers of electromotive force and potential difference both are correct. Both answers are correct. Okay, here they say that clearly say that then when the switch is off. Switch off means electricity is not drawn from the cell. I will show this point in a textbook. Here you can see lesson current electricity. Give a minute for me. Here, the electromotive force of a cell is equal to the potential difference between the terminals of the cell when electricity is not drawn from the cell. Okay, you can highlight in your textbook or you can write a note in your writing book. Okay, accordingly, here both answers are correct. Electromotive force and the potential difference are equal. But let's look at the fourth answer, voltage. What do you mean by voltage? What's voltage? The unit used to measure the potential difference is the volt. The force by which, okay, voltage is also potential difference, equal to potential difference, because voltage means we know that the unit used to measure the potential difference is volt, so voltage means the potential difference. Second answer, third answer and the fourth answer, all those three answers are correct. There's an error in this question. We'll see. Okay, let's move to the next question. Select the circuit which glow bulb brightly. Consider resistance of each resistor is 2 ohm and bulbs have equal specification. Okay, let's find the bulb glow brightly. They say that all the resistors have the same value, it's 2 ohm. Here 2 ohm and 2 ohm. Here 2 ohm. And here also 2 ohm. We know that in parallel combination method, here in parallel combination method, to find the value of the resistance, we should add the reciprocal values. Accordingly, 1 over 2 plus 1 over 2. Generally, we know that 1 over 2 means half. Half plus half is equal to 1. 1 ohm. Then all these two resistors considered together and those 2 ohms plus 2 ohms. Then those are in series combination method. Accordingly, 1 ohm plus 2 ohm plus 2 ohm. Accordingly, the value of the resistance of the first answer, first circuit, is 5 ohm. Let's write it here. Here 5 ohm. Let's erase other things. Okay. Next, let's find the value of the second answer, second circuit. Here 2 ohm. Here 2 ohm. 2 ohm. 2 ohm. Then we know that 2 plus 2, not 2 plus 2, it means 1 over 2 plus 1 over 2 because parallel combination method. Accordingly, half and half is equal to 1. Here also half and half is equal to 1. 1 plus 1 means 2 ohms. So the resistance of circuit, second circuit, is 2 ohm. Let's write it here and erase other things. Let's find the value of the third circuit. 2 ohm, sorry, 2 ohm and 2 ohm, and here 2 ohm, 2 ohm. Then here 2 ohm plus 2 ohm, or 2 plus 2, it means 1 over 2 plus 1 over 2 because the parallel combination method. Accordingly, answer is 1. 1 plus 2 is 3. 3 plus 2 means 5. Here also the resistance of this circuit is 5 ohm. Next question. Here. Not next question. Next answer. Next circuit. 2 ohm, 2 ohm, 2 ohm, 2 ohm. All those resistors are combined in series combination method. Accordingly, 2 plus 2 4, 4 plus 2 6, 6 plus 2 8 ohms. Then you have to remember the other point. Other point means when the resistance of a conductor increasing, the current flow through the conductor is decreasing. And when the resistance is decreasing, the current flow through the conductor is increase. You can use I instead of using C. Okay, it's the standard unit used to demonstrate current, I, capital I. Anyway, when current is decreasing, the brightness of the bulb also decreasing. When the current is increasing, the brightness of the bulb also increasing. Accordingly, the brightest bulb, that means the bulb glow brightly in the circuit with very low resistance. So the correct answer is the answer with the diagram with low resistance value. The correct answer is second answer. Here the resistance is only 2 ohm. So the correct answer is second answer. You can correct your answers. If you have any doubts, you can call me and ask. We have discussed those things in theory class in detail. Next question. Which circuit have the same amount of equivalent resistance between P and Q? Okay, here 4 ohm plus 4 ohm. Here in parallel combination method. In parallel combination method, to find the value, we can add 1 over plus 1 over 4 plus 1 over 4. That means 2 over 4. 2 over 4 means the reciprocal of the value. Accordingly, to find the correct value, we should reciprocal again. Yeah, we should change the side denominator and the numerator as 4 over 2. That means 4 over 2 means 2 ohm. According, here at the P resistance value is 2 ohm, at the Q resistance value is 2 ohm. So the first answer X is correct. Here an equivalent resistance. Okay, 2 ohm and 2 ohm. Y in Y 4. Let's erase other things. Let's write only 2 ohm here. 2 ohm plus 2 ohm here. Okay. Next one. 4 plus 2. 4 plus 2 means in the here the circuit in parallel combination method. Resistance are combined in parallel combination method. That means 1 over 4 plus 1 over 2. 1 over 2 means same denominator. 1 over 4 plus 2 over 4. Then 3 over 4. And the next one is 2 ohm. We know that 3 over 4 means the reciprocal of the value. So we should change the denominator and the numerator again. Accordingly, 4 over 3 ohm. You don't want to find the correct value. They asked only the circuits have the same amount of equivalent resistance. So you don't want to find the correct value. Okay, let's write it here using the brown color. 4 over 3 ohm plus 2 ohm. It is other things. Okay, next question. No, next answer. Here 2 ohm plus 2 ohm plus 3 ohm. Let's look at 2 ohm plus 2 ohm plus 3 ohm. 2 ohm plus 2 ohm. 2 ohm plus 2 ohm means 1 over 2 plus 1 over 2. Generally, we know that half plus half is equal to 1. So here 1 ohm. 1 ohm plus 3 ohm means 4 ohm. So let's find the circuit with equivalent resistance here 2 ohm plus 2 ohm when connected together in series method is 4 ohm. Here we don't know the answer. Here 1 ohm plus 3 ohm, that means here 3 plus 3. Okay, 1 ohm plus 3 ohm means 4 ohm. Accordingly, circuits X and Z have the circuits X and Z have the same equivalent same resistance value between the P and Q. So the correct answer is third one. Third answer is the correct. Let's move to the next question. In which of the instances below can the glow of the bulb in the circuit be increased? They ask, in which of the instances below can the glow of the bulb in the circuit be increased? We know that the glow of the bulb depends on the current flowing through the conductor, and the current flowing through the conductor is depend on the resistance of the circuit. When one more than 2 ohm resistor is used in series to the 2 ohm resistor, we know that in series method, here 2 ohm resistor already exists, and when we connect another 2 ohm resistor, we can add 2 ohm plus 2 ohm, that means the resistance is 4 ohm. When one more than 2 ohm resistor is used in parallel to the 2 ohm resistor, we know that in parallel method, to find the value, the reciprocals 1 over 2 plus 1 over 2, that means generally half plus half is equal to 1 ohm. Then in second instance, the resistance is only 1 ohm. When one more bulb is used in series to the bulb in the circuit, we know that when connecting a bulb in series method, the electricity is divided between two bulbs, then the brightness will be decreased. Okay, you can search it at Google. Can you see here? In parallel, both the bulbs will have the same voltage across them as that of the battery. However, in series connection, the voltage gets divided between two bulbs. Okay, so the bulbs which are connected in parallel are glow brighter. That means in series, it will not show a high brightness. Accordingly, third answer is also incorrect. Fourth answer, when the overall equivalent resistance of circuit is increased. Overall equivalent resistance of the circuit is increased means the resistance may increase. We know that when increasing the resistance, the current flowing through the conductor is decreasing, that means brightness will decrease. Accordingly, fourth answer also incorrect, third answer incorrect, second answer incorrect, the first answer is correct. In only series method, second answer is correct. In parallel method, resistance is 1 ohm. In series method, resistance is 4 ohms. We have calculated previously. Accordingly, the correct answer is second one. Correct answer is second one. Let's move to the next question. P and Q are two combined resistors. When supplying some amount of voltage between A and B, which is correct about the current flow compared to system Q. Okay, here they ask amount of voltage between A and B which is correct about the current flow compared to system Q. Here there's a relationship. What's the relationship? The relationship is V equal IR, no? Voltage is equal to current flow into the conductor into resistance. Okay, let's find the resistance first. The resistance of the first circuit, that means P circuit, 2 ohm plus 2 ohm. 2 ohm plus 2 ohm means here in parallel combination method, accordingly 1 over 2 plus 1 over 2, that means 1. Okay, here 2 plus 2 in series method, accordingly 4 ohm. Okay, what they ask? 4 times of current flow of P. Current, we know that V is equal to I into R when resistance is 1 ohm at circuit P. Resistance is 1 ohm at circuit P. That means the current flow through the circuit P is equal to, generally, I1. Let's take it as I1. Can you understand what I'm saying? Here V is equal to I into R. I into R, when R is equal to 1, that means I into 1 is equal to I. Then in Q, V equal IR. We have already found the value of the resistance as 4 ohm. Then R is equal to 4. Okay. Then the current flow through this conductor is 4 times, because I into R, accordingly 4I. So now you can find the relationship here. Here the current is 4I, here the current is I. That means the current flow through the circuit Q is 4 times as P. 4 times of current flow of P. First answer is correct. Okay, you can find here. Here the current is I, here 4I. Okay, the first answer is correct. 2 times, not 2 times, 1/4 of times of current flow of P. No. Equal, no, not equal. The first answer is correct. You can correct your answers by pausing the video. I'll erase those things. Let's move to the next question. What is the value of permanent resistor shown in the diagram? Here this diagram, you can cut this diagram. There's no any equation, no? You can cut this one. Cut this diagram. Next question. What is the value of permanent resistor shown in the diagram? We know that to find the resistance of a fixed value resistor, the first color band demonstrates tens place, and the second one ones place, third one is index, and the fourth one is tolerance value. Accordingly, the tens place is 2, ones place is orange, that means 3, that means 23, and the index value is again 2, that means 23 into 10 to the power 2. We know that to find the resistance value of a fixed value resistor, we should multiply the values of first 2 color bands by third color band. Accordingly, 23 into 10 to the power 2, 10 to the power 2 means 100. Accordingly, 23 into 100 means 2300. The correct answer is the second answer, 2300. You can correct your answers. Let's move to the next question. Which of the circuits given below are arranged to measure potential difference between the two terminals of the bulb and the current flowing through it correctly? Which of the circuits given below are arranged to measure potential difference? We know that to measure the potential difference, we should connect the voltmeter in series method or parallel method. In series method or parallel method, what is the method of connecting voltmeter? You should remember it. What's the method of connecting an ammeter to a circuit? You should remember it very well. Okay. To measure the potential difference, we should connect the voltmeter in parallel method and we should connect the ammeter in series method. Let's make sure about it. Connecting an ammeter series in parallel series or parallel. Ammeter are connected in series. Yeah, I told you correctly. Ammeters are connected in series method and the voltmeter should connect in parallel method to find the potential difference. We generally use ammeter to find the conventional current flow through the conductor. Accordingly, the first answer, ammeter is connected in series method, voltmeter also connected in series method. So first answer is wrong. Second one, voltmeter is connected in, can you see here? Voltmeter is connected in series method and the ammeter connected in parallel method. Total wrong. Third answer, voltmeter is connected in parallel method and the ammeter connected in series method. So this is the correct answer. In fourth answer, both ammeter and the voltmeter are connected in parallel method. So it's not correct. Correct answer is third one. Correct answer is third one. Question number not 29. Next question. If the bulb of the above setup is to be lighted up, which group of solution can be used as the solution? This is also a question relates to your lesson chemical bonds. We know that in ionic solutions it conduct electricity and the covalent solutions do not conduct electricity. So anyway, sodium chloride is an ionic compound, ionic solution. Glucose solution is a covalent solution. Sugar solution is covalent. Sodium chloride is ionic. Sodium chloride is ionic. Copper sulfate also ionic. So the correct answer is third one. Copper sulfate and glucose are covalent. Copper sulfate are ionic. So the correct answer is third one. Okay, students. This is the end of this video. You can correct your answers yourself by yourself. Okay, I will stop this video. Thank you all of you.